When you're walking on a street, let's say somebody comes to you and say, hey, electric potential at some point in space, let's call it point C, is 20 volt. What is the meaning of that statement? What would it mean? So by the end of the video, you'll be able to explain this statement in very simple terms to someone. To begin with, we are familiar with this word potential energy, and we've learned of potential energy when it comes to gravity. So let's start there. Say we held a 5 kilogram bowling ball in our hand, and I know bowling balls are a little larger than this, but imagine we held it at some distance from the ground, then we say that it has potential energy. Why do we say that? We say that because if I let go of that ball, then it's as it falls down, it's gonna speed up, and it's gonna gain kinetic energy. And we could ask, where did that kinetic energy come from? For example, let's say at this point we calculate and we figure out that the kinetic energy at this point is, I don't know, maybe 55 joules. And we don't have to worry about how to calculate that. Let's just take some random number. We could ask, hey, where did this 55 joules come from? Where was this before? Because energy can neither be created nor destroyed. And so we say, this 55 joules was already stored in the ball even before releasing it. And that energy is what we call potential energy. And so according to our example, this ball now has a potential energy, and the symbol we use for potential energy is usually U. And we say the potential energy of this ball is that same 55 joules. Okay? Now here's my question to you. My question is, a 5 kilogram ball held at this point has 55 joules. How much potential energy a 1 kilogram ball held at this same point have? Can you pause the video and think about this? All right, hopefully you've tried. So you might know that less mass means less potential energy. In fact, if I have only 1 kilogram, 1/5 of the mass, then even the potential energy would be just 1/5. And so 1/5 of 55 would be just 11 joules. All right. And so you know what I can do now? I can get rid of this ball, and I could say at this point, and I could put a indicator, I can label that point and say, let's call it point A, and I could say at this point, the potential energy is 11 joules per kilogram. That's how we can write. And what this means is if I were to keep 1 kilogram over here, it would have 11 joules of potential energy. And this number, how much potential energy you get per kilogram, is what we call potential. And we will write A over here because this is potential at point A and this is potential energy at point A. So do you see the difference between them? Potential is just potential energy that 1 kilogram would have. It's an indicator. Just like how when you go to grocery stores, you have indicators over there which says, hey, 100 rupees per kilogram. This means if you buy 1 kilogram, you pay 100 rupees, but it could also mean that if you buy 3 kilograms, you have to pay 300 rupees, and so on and so forth. Similarly, it's an indicator which says, hey, if you keep 1 kilogram, it would have 11 joules of potential energy, but you could keep 10 kilograms over here and it would have 110 joules of potential energy. So that's what gravitational potential is. So this is gravitational potential. Similarly, we can now define electric potential. So let me consider an electric potential case. So let's say we have something very similar. We have now a bowling ball which is charged because we want electricity. And let's say it has 20 coulombs of charge, a lot of charge. And let's say we have another huge charge which is negatively charged over here, somewhere down over here. And so now we have a situation which is very similar to that of gravity. If I were to let go of my hand, we know that that thing is going to get attracted towards this, and let's assume this is fixed then for simplicity, okay? And then it's going to get attracted and it's going to gain kinetic energy. And just like before, let's take some random number. Let's say that it gains a kinetic energy of, I don't know, maybe 100 joules. As an example, we could ask, hey, where did this 100 joules kinetic energy come from, right? And then we could say, that energy was already stored before. And we could now say that all that 100 joules was stored as potential energy. And I could now ask the same question as I did before. If 20 coulombs of charge at this point has 100 joules of potential energy, how much would 1 coulomb have at this point? What will be your answer? Well, just like before, it's going to be 100 divided by 20 coulomb. It'll be 1/20th of that. And so we can now get, just like before, we can now get rid of that ball. I can put a label over there at that point, and I could say, at that point, the potential energy would be 100 divided by 20, that is 5 joules per coulomb. And this number is what we would call electric potential at point A. So now again, do you understand the difference between electric potential and electric potential energy? Potential energy, potential is just potential energy that 1 coulomb would have. It's an indicator. All right, so we can now define what electric potential is. Let me write that down over here. So in general, what is electric potential V, say at any point P? How do you define that? We could say that's the potential energy. Let's write that quickly. Potential energy, a 1 plus 1, we have to be careful about charges, so that it's positive or negative. You always consider plus as a standard. A plus 1 coulomb charge would have its potential energy per coulomb. And the way you calculate is you take the potential energy and you divide by the charge to calculate how much you get per coulomb. And the unit for that would be joules per coulomb. But it turns out that joules per coulomb is also called, because it's used so often, it's also called volt. Named after the physicist Alessandro Volta, who invented the very first battery. Okay, so volt is just joules per coulomb. And so now we can go back to our original question. If somebody says at some point C, just random point in space, that potential at point C is 20 volt. What is the meaning of this statement? Can you now explain this to someone? Pause the video and think. All right. We can now say, hey, first of all, volt is joules per coulomb. Remember that, and then you'll be fine. So we could say this means it's 20 joules per coulomb. And what it basically means, it's saying that if you were to keep 1 coulomb of charge at this point, it would have 20 joules of potential energy. But it's an indicator. So you can also mean that if you keep 10 coulombs of charge at this point, it would have 200 joules of potential energy. So remember, potentials are just indicators that we can add to any point in space. Now, of course, before winding up, I do want to mention that there are more than one ways to define electric potential. And maybe the most standard definitions are different, and we'll get to that. So we'll talk more about what does it mean to have negative potential energy or negative potential. What is potential difference? We'll get to all that fun stuff in the future videos.